Imagine a car that can see, think, and react faster than you. A car that warns you before a crash or even prevents it. Hi everyone, welcome back to our YouTube channel Core Classroom Learning and welcome to the world of Advanced Driver Assistance System or ADAS. In this video, we will break down what ADAS is, how it works, key features, and why it's shaping the future of driving. ADAS stands for Advanced Driver Assistance System. It's a collection of technologies designed to assist driver and improve safety. Instead of fully driving the car, ADAS acts like a smart co-driver. It uses cameras, radar, ultrasonic sensors, and sometimes also lidar. These systems continuously monitor the environment around your vehicle. Now let's see how does ADAS work. ADAS is essentially a real-time perception, decision, and action system, similar to how a human driver operates. Now let's see what goes behind it. Number one would be environmental sensing. This can be called as a perception layer. So basically what ADAS will do, it will start collecting the data from the surroundings using multiple sensors. Okay. So basically it uses cameras. What cameras will do? They will detect lanes, traffic signals, vehicles, pedestrians, and so on. Okay, so this basically works like human eyes. And this is used in your lane keeping assist and also traffic sign recognition. Then it also uses radar. What does radar stand for? Radar stands for radio detection and ranging. What radar does? It basically measures the distance and speed of objects. Okay. So basically, radar is something that will work well in different conditions like fog, rain, or even if it is night. Okay, so it's basically used in something called as adaptive cruise control and even your collision detection. Then you have ultrasonic sensors. Now these are basically used for short range, mostly 0 to 5 meters. Okay, so they are basically used in like your parking assist or your obstacle detection. Clear? Then, like I said, that we sometimes also use lidar. These are usually optional in advanced system. So what lidar does, it uses laser pulse to create a 3D map. It's very accurate, but very expensive. So that's why it's like an optional thing. Okay. So what is the key idea behind all of this? The key idea is that each sensor has its strength and weakness. So ADAS uses sensor fusion, which means it combines all the data. So now next step is your sensor fusion and data processing. Clear? Now we saw that using different sensors, it has collected all this data, but what happens next? So all this sensor data basically goes to a central control unit, which is called ECU, Electronic Control Unit, or ADAS controller. Okay. Here what will happen? Something called as data fusion. Now what is data fusion? So basically, here it will combine inputs from camera, radar, plus the sensors. Then it will remove all the noise and even the errors. And then finally it will create a single accurate model of surroundings. Then what happens? We have object detection and classification. Okay. So basically what it will do here, it will use some AI algorithms to identify system like vehicles. It will identify like pedestrians, cyclists, and so on, lane markings, a lot of things. Okay. After it is identified, it will do something called as localization. In localization, it will basically determine vehicle position within lane by using GPS and some camera based lane tracking. Okay, so what do you get as an output in this step? A digital map of everything around the car in real time. Okay, so now you've collected the data fusion has happened and it has gone to your main controller, which can be your EC or your ADAS, right? Now let's see what happens. Then comes an important step, which is decision making, or I would call it also the planning layer. So basically here, the system decides what it should do next. Okay, so what it will do, it will use some algorithms and it will use some AI models. What will happen? Some rule-based logic will be there. Something like if then conditions and some machine learning models will be there. Some pattern recognition. So what happens? So let's say you are driving and the vehicle ahead slows down, so it will reduce the speed. If lane drift is detected, it will correct the steering, and if collision risk is high, it will apply brakes. So basically, this stage is very crucial or critical to calculate what is the safe distance, what is the required acceleration or deacceleration, and your steering angle. What should be your steering angle be? Clear? Now it has decided and checked all the algorithms, AI models, everything. So the planning part is done. Now it has to implement, right, all of this. So then comes your vehicle control or action layer. So now after decision, ADAS will send commands to your actuator. So what can be that? So for example, to your braking system, okay, to apply, it can send a command like to AEB, which is nothing but apply automatic braking. Then it can send to your steering system for lane keep assist to basically adjust the steering, and to, of course, throttle control, which basically controls your speed or is also called adaptive cruise control. Clear? So these actions happen within milliseconds, often faster than human reaction, which is almost 1 point, approximately 1.5 seconds. Okay. And another key thing to note is that this all is a continuous feedback loop. Okay. So basically, ADAS works in a loop. It will sense, then the process, then decide, then of course it will act, and then repeat. So it will be ongoing. Okay. So it will update every few milliseconds, and it will continuously adapt to your changing conditions. So these are the major 5 steps that happen or take place. Now let's see what are some of the challenges that take place in ADAS. Even though it's advanced, it has, of course, some limitations. First is your environmental issues. First, like rain, fog, dust, it can all affect the sensors, right? Then can be your poor infrastructure, means if there's faded lane markings, if the roads are unclear and so on. And then, of course, edge cases, which means unexpected human behavior, right? So these are some of the major challenges of ADAS. So to quickly summarize, we saw what ADAS is, what does it mean, how does it work? So it works in these steps: the real-time decision making and action system. What does it first do? It will have the perception layer, where it will have multiple sensors and so on working together that will collect the data. After collecting the data, it will go for processing. So it will be sent to your controllers. Over there, data fusion will happen. After that is your planning layer or decision making. So there will be some algorithms and AI models that will work together, and based on the condition, it will see what should be your action plan. Then, of course, your action layer, where the action is implemented. For example, if it has to apply brake, if it has to change the lane, and so on. Then we saw that it's a continuous feedback loop, that it senses, it processes, decides, acts, and repeats. Clear? Then we also saw a few challenges of ADAS. So now you know how ADAS is transforming modern vehicles, making them safer, smarter, and more intelligent than ever before. But remember, these are designed to assist, not replace the driver. So always stay alert and drive responsibly. In the next video, we will see what are the different layers of ADAS. That means 1, 2, 3, 4, and so on. And how is it different from one another? And to what extent is already implemented in what regions? If you found this video helpful, don't forget to like, share, and subscribe for more automotive tech content. Let me know in the comments, would you trust a fully autonomous car? Thanks for watching, and I'll see you in the next one.